research and academic teaching on digital fabrication, and it's basically widely spread and well known. But if you look at the architectural practice today, that you see it's hardly ever implemented, only by a few idealists who are, advancing the technology and creating fantastic work. And we'd like to hear about this type of work in this Digital Maker series. That's why we founded this series, because we'd like to introduce this new kind of technology into the practice of architecture, because we think that now is a different time where we can actually not just design as architects, but we can actually produce. And we're very well equipped as architects because we can deal with digital design, and everyone who can deal with digital design can also implement digital fabrication. So we think there's a new era, there's new possibilities of architectural fabrication, and we think it's going to change in the future. And we wonder, how can it be implemented? Because somehow we all know construction is a very slow business, and we want to know, how can we actually introduce digital fabrication in architectural making? So that's why we invited these distinguished speakers for the next 2 days. The first one tonight is Jonas Lundberg from Sweden, sitting in Sweden at the moment. And in the background, you can see already, I guess, some of the space that you are working in. Jonas has, I know Jonas since 1995, when we both went to the Architecture Association for our postgraduate studies. There was a course that was called Grad Design. It was kind of not just spearheading the education of Architecture Association at the time, but also trying to form a group of people who then spread out into the world to develop very critical design in their countries. And Jonas has been part of a larger group since leaving the course and finishing the course. And this group's called UFO, which is basically abbreviation of Urban Future Organizations. And it's a larger group of architects spread around the world, not just in Europe, but also in China and in other places. And they're all, their work is very much based on experimentation and developing critical and, it's a complex design. And I think that's part of all your work, Jonas, that I've seen. And you also not just work as an architect, you work as an academic educator and researcher. You are not just working at one university, but at 3 universities. You work at the Architecture Association in London, the Metropolitan as well in London, and at Chalmers University of Technology in Sweden. And I believe you're dealing with different ways of educating in these different universities, and I guess we're going to hear a bit about that tonight. And we're looking forward to having this lecture, which is not going to be, we agreed, not a normal kind of lecture where we say we hear some talk about projects for 1 hour, but we actually decided to make it into a short, small lecture bites that we then stop and we're going to discuss, and we'll at the end going to also invite the audience in to ask questions about your work, to understand how the digital fabrication may have changed your work, or how to implement digital fabrication in your work as architect. So yeah, so Jonas, the floor is yours. Welcome, and thank you for coming.
Thanks a lot, Martin, for the great introduction. So I'm very happy to be here with you, and I was actually a student in Stuttgart at the university 92, 93 when I did my second and third design at TU Stuttgart, and I also took Bauko, but in the other seats, so in IBK1. So it's great to be back, although it's quite virtual. So as Martin put it, I'm going to talk about this in 3 different phases. I'm going to just start my show here. Okay, so as Martin put it, I'm at many different places, but primarily I will be showing work done at Chalmers University of Technology in Gothenburg, Sweden, where my main employment actually is today. The talk that I'm going to be giving is called Hybrid Composites, between practice, research, and teaching. It's in this territory that I've been working for quite a few years. And as Martin put it, I'm at Chalmers ACE, or Chalmers Architecture and Civil Engineering in Gothenburg. I'm also teaching at London Met University in London, and the Architectural Association School of Architecture in London. So I'm going to show some work from all of these 3 institutions, accompanied by a couple of attempts of turning teaching and research project into practice projects in my own practice, Urban Future Organization. Today, of course, we are in this strange world looking at material resources in different ways. I thought this slide was quite interesting because it actually put the big bad wolf behind the house made of stone. Of course, the moral of the story here is if you plan more carefully, if you spend your time, you resource your construction better, you use more robust and permanent materials, you are safer from the threats of the environment or from other kind of external sources. But as we know today, I think these things are a bit different. I think you can actually think about a straw building or a timber building in many ways might be more appropriate than making a building in stone, which this has been the case in history, whereas stone somehow has represented permanence for us. So what I'm interested in is it's how we can harness the idea of innovation in different ways. And it's this question that kind of goes through all my teaching, research, and practice work. It is about trying to be at the forefront of new development and try to figure out how we can learn new things and try to understand what is interesting and what is not. And this is quite difficult, this image being from the late 1920s somewhere in Germany, where you have a new train and you have the old train. And of course, we know today that the steam locomotive very much outlasted the locomotive to the left. But at the time, when people were standing on the platform waiting for this train, that's not how they perceive the future. So I think it's important when you work on technology and you work on the development of technology that you try to understand where these things are taking you. So this talk is going to be focused around this quote. It's out of the book Roll Over Euclid by William Mitchell, when he's writing about how Frank Gehry designs and builds his buildings. So architects tend to draw what they can build and build what they can draw. So I have divided this talk into 3 different phases or 3 different stages. The first thing, it's for buildings that we cannot build. We might be able to draw them, we might be able to imagine them, but we might not be able to build them, or they might not make sense as buildings yet. These type of projects are very important for how to evolve the way we think about digital making or digital technologies or emergent technologies in general. The second project I'm going to talk about, or phase 2, it's what I refer to as hybrid composites, where we try to evolve the making aspects in parallel with the representation aspect of what we're doing, to try to put a development of the computation of what we're representing together with what we're making. And then the first phase, and that's the work done at Chalmers. And then the first phase is the work done at the Architectural Association School of Architecture, where we try to work the other way around. So there we try to build things that are impossible to represent, and then try to work out different ways that we can take them apart, draw them, model them, and try to understand what we made. And this is done by studying natural phenomena. So I'm going to go through these different things. There are not that many slides, but I think this is quite important. So part 1, drawings of things that we can't or shouldn't build yet anyway. So this is the work done at London Metropolitan University Diploma Unit 4 and at Urban Future Organization. So this is the Dome of Manhattan. You've probably seen this project, and you also know this architect. And I'm not going to talk about the project itself, but I think it's the importance of actually building big. So at our diploma unit at London Metropolitan University, we are thinking about impossibly big projects that don't make sense, projects that are on a geological scale, where we try to use computation, digital fabrication in trying to consult with different peoples to ask difficult questions about how we organize things that we maybe are not building yet, or they may not be able to be built in the future because they are so resourceful consuming. So in this case, we're imagining working on buildings in timber or composite uses of timber on buildings that approach twice the height of Frank Gehry's or Frank Lloyd Wright's Mile High City. So this building we see here is close to 3 kilometers tall, meaning that this is a building that you live in. It's a vertical master plan. Now, why are we looking at these projects? I mean, for once, if you were to build something, you have to think about computation in a different way, and you have to think about the relationship between how you plan this and how you build this. And of course, the digital model here is quite important. So this is related to an idea of building digital twins, which is an idea of actually making a digital version of the built reality. And in this case, of course, this is a project that is using an AI to basically plan, organize, and voxelate this project. And then through consultancy, the students have been working out its structure or structural principles. And here you can see a quick comparison in the type of scale we're looking at here. So if you look at the building to the right, is the Jeddah Tower, which is planned to be 1,000 meters. And of course, it's relatively small compared to this. Or you can see the Shard in London, which is also relatively small. Now, why do we look at these type of projects? We don't look at these projects because we think we should build this, because they don't make any sense environmentally. But we work on these projects in order to ask difficult questions about how we do things, how we build, how we look at different systems in the building, how we can push the materiality and the structure and the way we work with consultancy in different ways. And then we also try to work on impossible questions like how much water does a building like this consume? Or how much energy do we need? Or how much energy is embodied in this? Now, the reason why we do this type of projects, it's not necessarily because we are going to build this like this, but we can use this as a test bed to try to figure out which type of technologies are used in different areas of this project, that we then make smaller projects of, that we make physical tests of when it comes to manufacturing and making, that I'm going to show in the next sections. And for us in practice, what does this mean? Well, this is the front page of The Guardian. It's a relatively old project right now, but we made a competition with Urban Future Organization, my practice, where we were speculating of what a big building like this, it has 3 towers, one 680 meters, one 580 meters, and one 480 meters. How they could possibly be done as a city, but made in renewable materials. And of course, this was a concept competition. It didn't turn out. We won it, or we got the first prize, but it hasn't been built. But it raised a number of questions about what these type of buildings could be. And then we tried to translate that on other scale projects. So this is another building we did in China, looking at engineered timber, that we've done many small scale projects using the same technology in Sweden. But here we try to push the technology bigger. So to make 2 towers that are 75 meters and 2 towers that are 100 meters in engineered timber. And in this case, of course, the link between the design and the thing that we fabricate and that we make, it's very concrete. Okay, so that was the first part. So basically, my intention here was just to provoke this question about why it is important to think big. When do you want to develop or evolve different types of technology when it comes to the way we conceive of buildings and the way we conceive of fabrication and making using emergent technologies?
So when you talk about like draw what they can build and build what they can draw, I find it super interesting because it immediately, provokes the idea that there's some relationship between designing and making, and somehow, this is of course what we like to explore, like is this relationship between design and making. And if you are designing, you have to understand how to make things, and if you make something, you have to understand how to design it as well. So I think there's a kind of interrelationship that is being basically increasing, I think, in the last years through these new technologies that we have. When you then introduce your tower designs or developments, where you say you go to the most extreme, basically you go to such a size that you cannot build it anymore with what at the moment we know. So I think there's always saying that you can build anything, but you're trying to push that boundary to say you can't build it anymore because it's so huge at the moment. You can't build on that scale, and because it will have all sorts of consequences, because then these buildings become like cities. And I think what I found interesting is that so you're trying to test the possibility and the kind of things that you can't make. And I wonder, is that something, because in the light of digital fabrication, are you relying on technology to to make these buildings, or how do you? What is your vision? How you would like to implement them?
Maybe the way I look at this, just to clarify this again, that I quote from Rollover Euclid by Mitchell, is really this idea that as architects, we represent buildings. We represent the things we want to construe as architecture. And if you're limited to the way we represent things, we can't advance the way we build. And if we're limited by the way we think about buildings, we cannot also not evolve the way we represent and think about how we model or design buildings. So this first part is really about this. It's about challenging the scope of what we conceive of as buildings in order to put minds at work with trying to resolve the difficulties. So we work on technology in order to create these. So we work with AIs, we work with different type of algorithms to think about something like this big. And then we put that in front of other technical experts. So the students are then consulting with engineers from Arabs, for instance, who then look at, if you think about something big like this, then what do we need to do? And what type of technologies do we need to develop in order to think about these problems?
You mentioned like the Frankfurt White Tower, which was basically a pure utopism. It was kind of an image of a potential future. There was even some like drone type helicopters flying around, and I'm just thinking that was kind of trying to think to the future, like what could it be like to advance architecture in that scale. But what you're suggesting now is that you really want to know how to do it and how to make this, and to expand basically scale in order to find out what all these subjects are. Do you think we have kind of now, with this kind of new ways of doing architecture, we have like different tools at hand that allow us to make it happen, or is that closer?
I think we have this the key note speaker at the Smart Geometry conference that we hosted at Chalmers some years ago was Charles Baker from SOM. And he basically said that you can make a building that is 8,848 meter plus 1 meter. So 1 meter taller than Mount Everest. It's the limit to what we can build. But currently, does it make sense? That's a whole different question, right? I think he was just kind of provoking this, that under the type of engineers that we work with as well, they also think everything is possible. It doesn't mean that everything is good or everything is sensible. But lots of things are possible to do. And generally, this type of cataclysmic events that you're exposed to, I don't know, a famine and a national disaster, a war, a conflict, or a new challenge of large proportions will evolve technology much faster. And these type of projects at the moment, I think the industry is not so preoccupied with them. But if you looked at the 60s and the 70s, lots of the things that we see today is the result of many of those speculative projects, which is kind of interesting. But today, we don't give maybe those projects enough thought because they help us advance technology.
So you think that like we're at the moment more like driven? I mean, why is that we're not looking at this at the we always have been looking at like the utopic kind of settings to find out what the boundaries are. But somehow you're right. I mean, the recent years there has been a kind of deviation from that, and things are actually happening. Some things are happening that we couldn't think of. I'm looking at and thinking of like fantastic drawings by Finsterlin, for example, of buildings that look like somehow moving animals, landscapes, but not like architecture. That now seems possible to build. So this kind of utopism is something that has kind of vanished. And the question for me is, did it happen because now we can actually realize it? Is it something that we can actually we become more doers than the thinkers?
I think it's a good question. I think my answer is this: just as when it comes to ideologies and so on, I think, and maybe the only ideology that we have today is it's different versions of capitalism. But that also pans out in society, that if we are engaged with something today, we are more activists than we are so reactionist. We react to something that is happening in society. We are not necessarily inclined to project or speculate on alternative futures, but we react to things that we see are problems or things that are wrong. And that could be in relationship to the environment or in relationship to the use of technology or vaccines or whatever, right? But I think this role of these projects have disappeared, but it's also because there was a generation of architects who came up through relatively good times, but it was times that were owned by industry to a degree. So there were many architects who didn't have enough work to do, that were given plenty of time to think about what they were doing. And today we are so consumed by just surviving, having enough work that we can tick over, because it's very expensive to operate a practice today, or very expensive to be a researcher today. You can't just hang around a university and work on your visions for many years. That used to be the case at the AA, for instance, that students who are good stay there for longer, just to work on all kinds of imaginary things. And that doesn't happen today. Today you buy an education, and then you look to be employable, to go out and work on the production of buildings. So it's very different. It's not the production of ideas, it's the production of buildings.
So what you showed us in the first lecture is basically showing that how you want to change it. I mean, you're trying to kind of change discourse and the kind of how you look at how you look at it critically, and how to at the kind of borderline of architecture, as far as I understand. So I'm very curious now to listen to your second lecture, where you can talk about, I guess, the second part, which is what they can draw, they build.
So now I'm trying to bring this together. So in the context of Chalmers here, we are basically working on how you represent and how you build simultaneously, right? So it's about finding a balance between what we evolve modeling, design-wise, representation-wise, at the same time as we advance the way we think about building it. Okay, so
Okay.
it's a different situation, different context.
Okay, cool.
So this is the material and detail studio at Chalmers. So every autumn we run the studio, when you go from design to or concept to design to fabrication, production, assembly on site, and an exhibition in the course of one semester. So this is quite a few years ago now. This is quite old. It was one of the first years this course was running. And it was working with a steel fabricator to make this pavilion outside the Art and Craft Museum in Gothenburg. And then another year, we were working in concrete, and again exhibited at the botanical garden in Gothenburg. And another year when we were working with Shelters for Humanity in making lightweight refugee shelters for Syria. And this was 2015. So these are relatively old projects now. But then many of these projects came to us by the type of suppliers or the collaborators we had. And we could not always decide which direction these projects were taking. So over the past couple of years, we worked a lot more with timber. And this is the kind of run-of-the-mill, looking at milling on the robot arm, itemize, trying to figure out what it takes to build these projects. And in this case, it's a pavilion to be built outside of Gothenburg using 3D printing and in combination with timber. And all of these type of projects kind of led up to this project I'm going to show you now, which is basically a project that is not just student-led, but it's a project that goes between an innovation project called Wood, and an innovation project called Smart Built Environment, and a couple of years of this material and detail studio. So we managed to forge a stronger relationship between the teaching environment and the research environment at Chalmers, in collaboration with industry. And what we're trying to do here, this is the outcome of a design that they developed in the studio called the Doodle Nest. And this is related to the Vinnova UD12 Wood innovation project that we were working on. In this case, looking at how you can print things in cellulose. But here, we try to make something a little bit more unpredictable. We don't try to make the cellulose just in layers, but we try to air print the material. So extrude the material in thin air for it to then, through its own weight, rest on the layer below. So this is basically an experiment in 3D printing where we can make this type of noodles that becomes the kind of thickness of the project. And this is done, of course, first here in cellulose on a small 3D printer. And then we scale these experiments up as part of the Wood 2. It's actually, yes, it's called National Research Project. It's more of an innovation project where we have, which is funded by Vinnova and Formas and the Energimyndigheten. So this is an application that is ongoing, and we are waiting for this to happen, where we can develop this technology further. And the picture we see here to the right is basically that studio project that we did, printed at the Research Institute of Sweden's manufacturing facility in Gothenburg, or in Mölndal in Sweden. And now we are getting a similar extruder like they have on their robot arm to our robot arm at Chalmers. So we're going to be able to do the same work, but we collaborate on these projects together. So what we see on the arm there is a pellet extruder. So it can take any type of thermoplastic material and extrude that under heat and pressure. So we can extrude lots of different materials using this extruder. So that was then situated as another project called Compound Cellulose in this material and detail studio, that we actually did one of the demonstrators for this project. So it's part of the Wood Innovation Project, and it's demonstrated 4. And what we were trying to do here is basically to try to figure out and not do what we did previously at Chalmers, where the manufacturers, the suppliers came to us and they told us what to do. And if you had to work with steel, well, then we worked in steel. If someone came with concrete, we worked in concrete, but this time around we wanted to set the agenda, and we wanted to connect it to the Swedish timber industry. And for those of you who don't know, Sweden is very large as a raw material producer, and we have lots of timber waste. So we were trying to figure out what to do with that timber waste, namely cellulose. And as part of this, we set up the studio brief in the autumn of 2019 called Compound Cellulose. It was demonstrated 4 in this project. And as you see here, we couldn't really do exactly what this doodle nest set out to do. So in a way, we have a much simplified structure here because we couldn't work, or the material when we scaled things up didn't behave in a similar way enough from how it behaved on the smaller 3D printers we had. So when self-weight became a central issue for the material, we had to simplify the structure a bit into this tessellated structure that you see here. And I think it's this process that we kind of find interesting in the way you start out setting an experiment of something that is really difficult to do. And then you try to experiment and trying to make that, and ultimately that you can kind of get close to this somehow. And this is in a way, the final outcome that we worked on in big scale. And in this case, we are developing this project in Wuppertal. It's a solar decathlon to 2021, which is now going to be 2022, in a project called Sea Hive, that we got now additional funding for another research project called Smart Built Environment, when we are actually trying to develop this technology so we can make a full-scale building using 3D printing or additive manufacturing in cellulose-based material. And as you can see here, we're looking at making this type of tessellated structure on the inside with a kind of customized interior with this post-tension roof where the kind of noodle nest is the thickness and the insulation of the roof. You can see the build-up of the systems here. And here are some of the details, of course, here printed in smaller scale. But this is the type of technique that we use when we make components that are put together on these, they're basically put together on these bamboo rods that go through the project. And the 3D printed parts are actually a bit smaller. And then the whole idea here is to try to make building parts, not make whole buildings, but that they are lightweight and easy for us to maneuver. So we can use them maybe for rooftop construction, for upgrading existing building stock, which is a big problem in Sweden, I assume also in Germany, where actually the biggest issue we have today is how to upgrade and densify existing building stock. So we're looking at this, and we then go from this type of innovation research project to the way we also implement some of these ideas in practice. So these are a series of kiosks that we did, not using cellulose necessarily, but also this is my practice, Urban Future Organization, where we connect in the idea of how they are made with the way how they are represented and conceived as geometry. And of course, in this case, we are using a hot wire on a robotic arm to cut this. And then this is the pavilion that we realized at the Dongdaemun Plaza in Seoul, outside Sarah's big project. So I think what I want to illustrate with that is that we tried now to embed teaching together with research projects that we work on, and then how I am trying to translate some of those ideas into smaller scale practice projects that we do. But these projects work in a different territory, because here it is both about how the digital content is created, but also very much about how that is related to the manufacturing and the tools that we use for the actual fabrication in this case. Yeah.
Great. So you are actually using, let's say, the academic field to explore new ways of construction. I hear also now trying to push the boundaries of materials, which of course is a major subject, because all materials we're using are not usable in the future. In the same way, we have to kind of reconsider all the materials that we use for construction because of the amount of CO2 they produce. There would be actually a change of materials. I think we're kind of realizing that there's a kind of crisis ahead of us where we're basically 2050, when all the states want to become carbon neutral. None of the materials we work with at the moment can be carbon neutral, except for the timber. And then everything else that is basically now, maybe happening in research. And I think that's super exciting to see that you're working in that field as well, trying to establish new materials by using digital technologies. So kind of marrying both materials and digital technologies to kind of develop new ways of construction. And I can see, of course, it's so experimental that it's really hard to imagine how to live in it in a way. But at the moment, but I think I can see that you're kind of researching in the academic field with like these different technologies, and then you're implementing it in your own practice. And the question I have is like, how does this kind of changeover happen? Because I mean, I always find that the time you have to build a project and for a specific client, is actually very limited. It doesn't allow you to implement research, and it's a really hard task to perform. So the question for me is like, how do you make that happen with your own practice of UFO?
Yeah, I mean, maybe I can start with this. So in a way, we're trying to combine teaching as a way of doing basic research, because I think in research today we have a big problem that we can't do enough of the groundwork or the basic work that is needed to generate material to have something interesting to investigate. So we try to use the studio context in order to generate information that we then can explore. We can explore the questions, the technology in the research projects, and then we take more of the development results coming out of the teaching to try to implement them in some of the innovation projects that we work on. And then from those innovation projects, then sometimes I must say this, that some of those students, after they finish, we hire, and then we try to do something similar, but not as an innovation project, but actually as an interesting way of developing a model for practice. So we don't take ideas directly from whatever has been developed, but we take some kernel of things that we want to investigate, and then we try to pick projects, smaller projects generally, kiosks in this case, my house in another case, projects that we don't have to make any profit on, where we have time, so we can really investigate how we are working. That's kind of what we've done with those projects. So, of course, we've done other things. We built a house using mushrooms. Mycelium in Colombia. We did a house some years ago, and
still standing.
It's still standing, yes. But they've asked if they can get rid of it now. Because it's alive. The whole house is alive.
So I mean, it's basically, this is the kind of question. I mean, there's, with all this experimenting, like, you actually apply it, and then usually what happens is you run away from the job. You just kind of give the key, and then you.
I mean, we don't experiment on our paying clients like this, but we do things when it's clear that this is an experiment, or
Right.
when we are the client ourselves. Right? We wouldn't do this on our own clients, who are paying us to do a professional job. I think that's a different thing. So we select these projects carefully. But some of that work also carries over to the bigger projects. That's why I showed you the tower early on. So the tower is basically a product of us doing lots of the smaller scale projects in CLT timber and composite CLT timber with post-tensioned slabs. And then we scale up some of those experiments to be able to make a 100-meter tall tower in collaboration with engineers. So some of the things that we do work on a small scale, and then we work with experts to try to scale up some aspects of that in other projects.
Right. So you mentioned the collaborators you work with. Like you have other, like you have students who have been working in a research field that their knowledge comes to your office, and then you have also engineers that you work with, also with maybe students in your studio. And I think that my question is like, how important is that you you have that interaction with other people about these, and how do you find them? I mean, and how do you get engineers to maybe leave their typical way of designing and trying to explore new ways of building?
I mean, I think it's simple. My answer to your first question, Martin, is I don't think you can make any interesting work without multidisciplinary collaborations and constellations. So you got to get producers, you got to get consultants, structural engineers, environmental designers. We work with fabricators, we work with material producers, and we also work with the type of venues where we exhibited some of these projects. And they are all part of the projects. And I don't think any of these projects would become anything as interesting if it wasn't a group effort. So I think consultancy to this type of work it's critical. I mean, if you made the tall buildings I showed in part one without consultants, it would just be a doodle or a noodle or doodle. And it would have no real relevance except for a vision that other people have drawn before you. But it's only when you can start trying to understand what those diagrams actually pose, what type of challenges they pose, that they become interesting.
Right. Well, I think that I mean, I'm looking at your picture behind you, and I'm looking at this kind of robot arm that is printing these noodles in some kind of timber clay material, and
cellulose.
Cellulose, exactly. So I wonder, like, how many people are actually involved in this, and I mean, I just wonder, like, isn't this kind of, a lot of people have this anxiety that these robot arms will eventually replace people, and then there won't be any work left for people, and so it's kind of apocalyptic scenario that the world is just full of robots and there won't be any work that needs to be done, so people are useless and they have to go away. But I think what you're saying now is kind of the opposite. You need more interaction between people to make it work, and to actually develop more connections with other disciplines to make it happen. And that's I think a completely different development that maybe 20 years back people wouldn't have expected.
I mean, I think it's an interesting point that you're making, Martin. But I think maybe it is possible to make things, but the question that I'm asking myself is, how do you make things good? Then I think you need collaborators, because they are the ones who actually give substance to any type of work, right? So I think that's why we choose to or try to work with experts. I think the whole idea with digital making from the beginning was this whole idea that, okay, I can buy all the means of production myself, I have my computer myself, and I can make everything myself, which many of these type of maker labs were about from the beginning, right? But actually, I think it just opens a Pandora's box of, I would say, not of limitations and problems, but rather about opportunities. That once you start doing this, you realize you can share information in different ways, you can share expertise in different ways, and because of the complexities of some of these undertakings, you have to learn from others in order to evolve it. And I wrote an article some years back called actually the de-evolution of technology, which is which the whole point of that being is that, and I also have a colleague at Chalmers, Chris Williams, that you might be know, who designed the glass roof of the British Museum. He is always worried about the kind of technology bloat or the software bloat, the fact that we go for digital fabrication, digital design, really advanced tools for the sake of the tools sometimes. And he is also always in our projects, he's trying to step us back and not always taking the route to the newest, the best software, the best machine, the newest thing, but always making us ask this question about, why are you doing that? Does it really make sense to make this in a robot? Maybe you would make this better by hand, or by, like we did this foam product that you saw. We started out first milling it on a robot arm. Then we started out with a hot wire on a robot arm. But at the very end of the day, we did templates on a laser cutter, and then we cut them by hand, because that was much faster and more efficient. So it's still kind of digital making, but we downcycled, let's put it that way. And then in that way, we found a much better way of making the things. So we're kind of interested in that it's not always the newest, the most advanced tool that is the best. That there is an artisanal way of actually thinking about digital making that makes it's more like an artisanal endeavor than what you first imagine, I guess.
So the human being as the kind of extension of the robotic production in a way.
Yes.
I mean, I had yesterday a client here in Berlin saying that you know, there's a very difficult site, and said we build in concrete, which we want to avoid. But I think that if we build in concrete, it's really going to be difficult to do the shutting work. But how about just printing the whole thing in concrete? So I think there's a. I was really shocked, because I've never heard investor asking whether you could go forward with printing, digital printing, and to actually introduce that technology. So I think there's a kind of changeover now that is a very accepted technology, and you know, the first houses are printed all over the world, in China and Holland and so forth. So I think there's a growing acceptance of that, you know, that technology. I think, you know, somehow I wonder what are the benefits, you know, what is because you mentioned it, like sometimes it doesn't make any sense to use it because it's just too difficult to steer, to make, to have, you know, at the end maybe it's easier to make it by hand. But sometimes, and that's kind of coming to the beginning of your lecture where you said like everything is, you want to be testing more complex ways of making architecture. It feels like you could need something like digital fabrication to create that complexity, to make it actually happen. So it's a kind of extension of your architectural thinking in a way. And so I'm wondering whether you see that kind of change happening, that all of a sudden you could actually produce and that these things, how will they filter into architectural practice and actually getting built? Do you see that as a possibility, or from your experience, is this just something that's going to stick still within the kind of research field, and it's going to take a long time until actually some of it's going to be realized?
I mean, I think it's already happening. I think it's already happening, but I'm not so sure if I think. In a way, what I'm thinking about this is like, and this is maybe because I have this privilege of working on some of these projects live. So I don't work on 3D printing in concrete because so many people are doing that and have done that for so many years. So that technology is relatively mature. So you can just order a concrete printer from China. You can get it, and they can print in concrete. And then we have many research projects also in Sweden today. Think, everyone has to do 3D printing concrete, but they're actually just repeating research that is already out there, which is I think we are trying to be at the forefront of where these things happen. When we make these. So I think 3D printing a whole building, that's kind of cool, but there are 3D printed buildings. But there are no 3D printed buildings in totally renewable materials like cellulose. Right. So I think we are just trying to go there, whereas I think these technologies will be implemented. I think even countries like Sweden, who tends to be very slow when it comes to industry, have more of a tendency to look at, let's look at what other people have done with it first to see if it's worth it. And then you can implement when you see, see if it works or not. But even here in Sweden, we are starting to talk about this now in the building sector. So I think all of these things will have a relationship to the industry, and it will change things. Do they always make sense? Absolutely not. Right? I mean, yes, shuttering is time-consuming, expensive when you do concrete, but you can also make formwork that is part of the construction. Right. So it's like and 3D printing is relatively slow. So it's like it's going to take a long time before 3D printing is a fast process,
Well, exactly. That's what I said. This was my argument, kind of against it, though I was really happy to hear about that proposal. But it is still a process. But I mean, Jonas, I just thought maybe you're part 3. I mean, I know you said maybe you don't want to listen to it, but I think I'd be curious to hear about it.
Okay.
Yes.
So part 3. So buildings that we can't draw yet, anyway. So this is the work at the AA School of Architecture, Diploma Unit 3 and Diploma 16. And there we work with the students on looking at physical phenomena, model making, and ways of producing physical effects through models or through prototypes that are incredibly difficult to draw and represent in drawings. There is this text that you might have read, The Second Digital Turn by Mario Carpo. I don't know if you know Mario Carpo, but I think he talks about this, actually it's in his first digital turn about Frank Gehry, about how many drawings you have to draw to make a potato. And if you think about making sections and plans, we have to make many drawings to produce these things. So here the students have to think about how they represent these physical phenomena that they create. So different order, but it's all about, here in this case, trying to advance the way how something is made and then how something is represented. Yeah, so this is our crazy studio space at the Architectural Association a couple of years ago. I think you've been there, Martin. You know the amount of models and experiments is pretty intense. And so in this case, the students are working on creating physical constructs or models of different phenomena that they try to find different ways of representing. So this is an example. This is actually polyurethane foam that is blown into a form and then carved into in different ways. Of course, if you were to draw this project using just plans and sections, it would be very difficult to construct this as it is here. So the students, of course, had to then develop a way of trying to understand the complexity of the geometry, try to develop the geometry of his models, and also find a way of representing this and to give some type of instruction for how this could be scaled up and thought about as a building. Another example here, looking at a lot of kind of linear extrusion. Here is like a hairy model, a little bit like the, what is it? Yeah, it's an old product. Sorry,
Heatherwick.
Heatherwick, yeah, his Shanghai pavilion. Yes. But the idea being here is that some of these things, in this case, this is a model where all of these pipes go in different ways. So it's actually a condenser of water. I think it's this particular product is done for Dubai, where you try to take water out of the sea breeze that you get. And again, the students then have to make these models, then they have to present and argue what these models are, and then try to figure out how some of those things might be represented and constructed. So in this case here, you see a student who's been working on making models by pouring wax in a bathtub, so in cold water. And then she had to create this type of manual algorithm when she had a particular order and way of regulating the flow of wax out in the bathtub to create these models. And of course, they're quite difficult to draw. So in this case, she was working on a way of 3D scanning, registering, and trying to take them apart as drawings to try to figure out how these were made up. And again, different examples. In this case, scans and drawings kind of mixed. And then this project is another student, Talia Frontini Matsura, a project that got distinction at the AA, an honors project, which started with these tessellated models about actually working on 3D printing using a 3D printed pen. And then she started to make these large models. And then she was interested in finding ways of connecting the way how you created the physical model with a 3D printing pen, in this case with a VR handle, so tilt brush in this case. So you could make both the digital construct, the physical model, and then the scaled up artifacts in the same haptic process by her drawing in 3D space. And then creating this kind of 3D painting in VR. That's how our models were made. and then you ended up with this type of point clouds or these paintings that she then developed as drawings. So here you can see her final presentation. So going from the model kind of to the left center of the picture into the way she was trying to take that model apart into different pieces to find ways of drawing it, and to the way this was drawn and represented. So I think why I want to show this project is that this is another example of something where it's another relationship between what is built in this case as a model that is represented and drawn, and then what is thought of as a construct that can be scaled up. So they do a technical study in this case, where they work with consultants for how some of these experiments can be scaled up as structures. So again, the idea of consultancy, multidisciplinary collaboration, but in this case, starting with a phenomena or a physical phenomena that is difficult to represent. So I also think these projects are really quite central in helping us evolve both what we draw and what we build, but here with a different relationship between them.
It's super exciting to see. I have to say, I'm very, yeah, I'm quite overwhelmed by the imagery, and I can see that kind of this immense experimentation, and I find that interesting because it's almost like in comparison to your first lecture, you have it's a different scale, but the same way of pushing the boundaries, like, because now we're as architects building models is like realizing the super skyscraper as a city. I can see this kind of relationship between these two scales, and I think there's something really exciting about how you push that boundary, but also try to introduce this kind of digital designing in a way. And all the models seem to be made physically, kind of almost like evolved, but then they are also re-evaluated by using the means of measuring and basically digital technology. And I think it's very exciting to see how actually the digital technology is not just by how to produce things, but also how it comes into kind of the experimenting during design process. I think that's yeah, fantastic. Jonas, I'd like to open up the questions by others. We have a lot of people here, and Simon and Piotr and Andreas, maybe you also want to jump in. I just want to ask if there's someone who would like to ask a question to Jonas. Someone from the audience.
Please, just jump right in. Yeah, but I just like I want to mention like one thought which came to my mind when you showed like this huge mega structure and like that this is not possible to build. If you think about like these megalithic structures, these megalithic tombs 10,000 years ago, if we think about the drawings, like the first guy probably was a guy who came up with the idea, hey, why not take that stone and put it up in the air? Like everybody must have been like, you're completely out of your mind. And then it became fashion. And our grandfathers must have had so much energy in terms of like food and supply and backup by their families and their tribes, that they just did this. This completely, for us, senseless architectural gesture, which is still, you can see like in North Europe, all over the places. And so I think it's not so silly to articulate like these fantastic thoughts. So and now like we have so much more tools on our hands to realize them and to find ways to do also the calculation that they stand up and
I mean, I believe in it, but so I very much believe in that. Now, if you look at this particular building, if you think about the amount of biomass that goes into the tower, you would need, in this case, we are speculating it in the southeast part of England, and it would need a forest of the same size to build it. So you will either have to grow it over a long time. So I think she was looking at 100-year time span, where you can have actually 2 cycles of forestry in that time, just to satisfy the demand for timber. So it's a big project. So I think technically it is possible. Does it? What I mean, that shouldn't be built or may not be built, is more. When it comes to resources and the way we think about it right now, I think the self-weight to material is still too great compared to the scale of things we're going to do. But if we develop new type of hybrids and composites in different ways that will be much lighter, then I think a product like this would make a much better sense as a building.
And like jumping to the pulp you've printed, like the cellulose pulp, what is it usually used for? You just is it like thrown away, or do they use it for making paper, or what is like the main use of the pulp?
Paper. You can use cellulose fibers for paper as part of the paper making process, but today, so in Sweden we had lots of big paper mills before. That did newspaper print and so on, whereas most of them are closed because of the current climate. So the forest industry has a lot more cellulose waste at hand than we had before. And I mean, it's used as fibers in many things, but the material that we're using is relatively new. It's Stora Enso's material that we're using.
I'd still like to invite the audience to ask questions. I mean, this is a chance to raise any questions to Jonas. I mean, you should use it, I think. So if anybody has questions about the making of models or the production of those, noodle structures and what they use for it, then please go ahead and ask the question.
Come on, guys, don't be shy.
I think.
Yes, I would have one question.
Right.
It was mentioned before that it's very hard to get clients to finance these projects. And I was thinking architects are doing chairs also, and much smaller projects on a smaller scale. Why isn't done this with these new technologies?
I mean, we do lots of projects on smaller scale. Actually, most of the things are done on smaller scale, I think. In a way, you saw the part 1 and part 3 here was about the importance of speculating in order to evolve the technology about how we represent and what we build. whereas the second part was basically more about that scale. It's more on a furniture scale, on a smaller thing. So in this Material and Detail Studio, we work on a spatial scale, furniture scale, maybe a pavilion. So I think, and also in our own practice, we worked a lot on interior projects, on smaller projects with this technology. Yeah, for sure.
Yes, I mean, I meant with a financial way of doing this. So mass production of small scale furniture, for example, to finance the bigger projects or things, because you don't have to think about so much problems with a chair. It hasn't to be waterproof or anything else.
Yes, I would assume. Just with that, I think there are 3D printed chairs, there are 3D printed tables, there are designs that are 3D printed, but because they are bespoke and 3D printing is still a relatively expensive technology, they are still relatively. I mean, there are furniture that you really want to own. They're not competing with IKEA. Let's put it that way, but they could be. So there is an old digital makers place in London that has been for a while called Until Things Last. When they started to make bespoke furniture quite a while ago on a CNC machine, and there you can go and order your own digitally made objects, furnitures, accessories, and different things. And it's kind of a shop, and you go in and order things, and they make it while you're in the shop. So there are digital makers that do that. I think in my case, I don't think we work so much on that particular scale. Yeah.
Thank you.
Thank you for the question. Is there any other question?
Yeah, thank you for your question.
I think we're also getting closer to almost 1.5 hours. I think pretty much 1.5 hours. I think so. We're getting close to the end of the lecture, the talk. I think this comes to the point where I have to say thank you very much, Jonas. It's super cool that you could come and show your work. I thought it was very exciting work. I mean, all of it basically, and I found very exciting how you really pushed the boundaries in different ways. And I wasn't aware of that, even though I know you for 25 years, that you're working on these parts. And I'm I know some of it, but I didn't know all of these, and I'm very excited to see it. And yeah, I can see there's obviously a lot of game-changing work, I think, in here, which hopefully will be picked up and will change also the way we look at architecture. So thank you very much.
Thank you, guys. Thanks a lot for having me.
And
I would like to invite you also tomorrow. We have 2 more lectures or 2 more talks from digital makers. Tomorrow there will be Jim Mendenhall from Zena.
who's in the audience? Hi, Jim.
Who's in the audience, apparently. And hi, Jim. Good to see you here as well. Yeah, so Jim is going to talk tomorrow and basically showing how some of these complex structures are being built worldwide. Buildings for Gary, for example, a lot of like iconic buildings that are realized. And then after that, we have Arthur Manumani, who will talk about his work in his studio.
You know that I know Arthur really well, right?
Yeah, I know.
Okay.
So you should inform him before and let him know what it's all about. But I think it's it's exciting to have him as well. He's going to talk about the
Galaxia.
Galaxia, which is basically for the Burning Man Festival, the temple, and some other projects as well. So, and also deeply, I guess, like an idealist also in that sense, driving forward the digital fabrication, making and designing. And so, I'll be happy to join. I'll be otherwise very happy to see you soon. I'm hoping that we can collaborate soon, Jonas.
Yes, let's do, Martin.
Let's do it, and we'll stay in touch. So thank you very much for coming.
Okay.
Great.
Thank you, guys. Thank you.
Thank you.
Thank you.
Thank you.
Bye.
Good night.
You too. Bye-bye.
Bye.